everybody. In this session, we are going to speak about how to use ProxySQL on top of TiDB. Specifically, we're going to describe the features of ProxySQL that can be used on top of TiDB. Quick introduction about myself and the company I represent right now. So basically, we are the developers of ProxySQL itself, and what we offer as a service is ProxySQL development, support, and the consulting service. A little bit about myself. I am the founder of ProxySQL. It was founded in 2017. Yes, I'm the initial author of ProxySQL, and my background has been as MySQL DBA for more than decades now. Okay, so now, what is ProxySQL? ProxySQL is a protocol-aware proxy for MySQL protocol. The fact that it is for MySQL protocol is very important because it's not just a layer 4 proxy, but it's a layer 7 proxy. This means that it understands the MySQL protocol. So in a nutshell, the way it works is that client connect to ProxySQL, requests are sent from the client to ProxySQL, that he will analyze them and make some decision based on the query themselves. Even today, I still during this conference, I get the usual question: why the DIA was started? What were the reason behind it? And I can describe the reason mostly as the fact that my view there is the application and database. They are two completely different layers. Like today, we are a conference speaking about HTAP, and we can tune the database as much as we want. We can have a very fast database layer, high throughput and low latency, and all this optimization you want that are very well structured. But from a database perspective, you do not have any sort of control of what queries are being sent by the application. So the application can generate query automatically through some RAM, and you have absolutely no way of controlling the traffic sent from the application to the database. So our idea is to absolutely fill the gap between the application and the database layer, and this is where ProxySQL fit. So the client will connect to ProxySQL, and then ProxySQL will connect to the database, and in doing this, it can perform a lot of operation on the traffic on the fly. So yes, we basically have the ability of build this database as a service that we're using our reverse proxy. So ProxySQL is a reverse proxy. Okay, so here is a list of one of the most important features. The features list is not completed, but yes, I'm trying to highlight the most important features. So it is extremely provide high availability and is extremely scalable. Like we have infrastructure in which we have thousands of servers configured behind one single ProxySQL instance. Of course, actually not every behind just one proxy, but behind every proxy SQL instance there are thousands of servers and can handle hundreds of thousands of client connection. It can handle all sorts of failover on the backend, so whatever it is, a planned or unplanned failover, ProxySQL can handle it completely transparent to the application. It does MySQL load balancing. We also have some interesting features that is like we can run two or more proxy on the same port. This allows a completely transparent upgrade from one version to another one, because we can have two proxy of different versions running on the same port. So the client will first connect to one, and then we can stop the listening of the instance, and all the new client will start connecting to the second ProxySQL instance. Okay, next. One of the most important features that we have is the connection pooling and multiplexing. This is extremely important. I'm going to dive into these features a bit later on. We have the ability of having query caching outside the database. And historically, what to do for query cache, you either use the MySQL query cache, but that is now being deprecated, or you use some sort of caching layer outside the database system. In this way, instead, we can have the caching that is basically on the wire between the application and the database. Because it analyzes the queries, it's also able to understand what the queries are trying to do. So it's able to perform routing based on the content of the query itself. And one of the classic one is doing read-write split. But actually, the routing could be on anything like username, query pattern, and so on. We have interesting features like query throttling, firewall, and mirroring. I'm going to describe those later on in a few more details. On-the-fly query rewrite. Again, we're going to describe this later on. Data masking. So like if you want to create some rules that will prevent users to access all your data, you can use these features that basically is able to hide some of the data from user's query. Other things, it is completely reconfigurable at runtime. So like there is only two conditions in which you need to restart ProxySQL: when you want to change the number of worker thread and when you want to change the port in which is listening. Anything else, it can be reconfigured at runtime with no need to restart. Because it's in the middle between the application and the database, it also collect any sort of metrics on the fly because all the traffic is passing through it. So it is like very easy to collect those metrics. It also has its own scheduler that is able to run external script, and those scripts can be used for really anything like monitoring of the backend, reconfiguration, and so on. Like imagination is your limit there. We also have causal read using GTID. I don't know who is familiar with GTID, but basically we can use GTID to know when transactions are being executed on the replica, so we know when we can send a certain type of query to the replica, making sure that basically the replica has the data that we already have inserted. And we also have clustering that allow us to have distributed configuration management, so you can apply any change to any proxy, and the change you apply to it will be automatically propagated to all the proxy at the same time. Okay, we have support for both front-end and back-end connection. Of course, the certificates are separated, but we have support for SSL. We support different MySQL clustering solutions. So we support Galera, group replication, Aurora, RDS. We also have ClickHouse as a backend. So you can use MySQL protocol to communicate with ProxySQL. ProxySQL can communicate to ClickHouse as the backend. This was before ClickHouse also had a MySQL connector, but we still have these features. And of course, being in this conference, we also support TiDB because it used the MySQL protocol. And again, as I was mentioning before, we really have very large infrastructure, and one single ProxySQL instance can handle millions of users and tens of thousands of database servers. When I say millions of users, I actually don't mean millions of connections, but actually distinct users, like user A, B, and so on. Like there are absolutely huge number of users. Multiplexing, I was saying this is one of the most important features, and basically is the ability of having a lot of client connection connecting to ProxySQL, and ProxySQL only using very few backend connections, and those backend connections can be used by multiple clients at the same time, in quote, at the same time. Like there are special conditions in which those backend connections can be shared between multiple clients at the same time. And here there is some graphs about one of our customers when we did some presentation together. Like before, when we were doing some benchmark, they had the client connecting directly to MySQL and had something like 15,000 connections. Then they switched to ProxySQL and the number of backend connections dropped to around 600. And this was during benchmark. And we can also have things like thread running. Of course, the thread running dropped drastically. And we're also getting better throughput. So the InnoDB thread inside InnoDB dropped drastically. Threads in the queue, before there were several threads that were in the queue. After they switched to ProxySQL, this completely dropped to 0. And this was during testing. Then when it actually went in production, this is real data. So actually, they initially thought there was some problem with the graphs because actually it's close to 0. Like it doesn't fit in the scale. So they passed from something like 25,000 connections to a database server to probably a few hundred or less than 100. So this is a very interesting features that we have. So what it means is that at this point, those roughly 100 connections were able to handle 25,000 client connection. And this is another graph about the MySQL thread. Again, you can say MySQL thread running before was elevated around 30, and it drastically drastically dropped below 10. And other metrics, so like total query times. Why multiplexing is important? Because if you have less connection to the database server, those connections are being utilized in a better way, and actually it also increases throughput. So you don't have only the number of connections that dropped, but also the execution time of every query that is improved, so they become faster. Okay, now some important concept about ProxySQL. ProxySQL, what it does is it divides servers into host group. From ProxySQL point of view, a host group is nothing more than a set of servers that has the same functionality, the same logical functionality. And here is a classical example. Like we have one ProxySQL instance with 3 host groups, and in those 3 host groups we have 6 servers. Host group 0 is, for example, a primary for writes. Host group 2 is replicas, so all the replicas are there, and we can have a host group 2 that is replicas that are used for reporting. So basically, just configure those servers in different replica. An important thing is that you can have the same server being present in multiple host groups. What ProxySQL does exactly with those servers, well, it of course sends traffic to them, but it can also do some more interesting things, like it's able to monitor them, so it knows when some error arises, when one of the servers fails, and it's able to detect failures, and also when a failover happens, this is automatically detected, and ProxySQL is normally able to route the traffic to a different server without the application even being aware that a failover happened. And this is extremely important because we have some retry mechanism. So if, for example, if you're running a select statement and the select statement is in flight and is being executed on a backend, and the backend dies, ProxySQL detect that the select statement is incompleted, and it will execute the same select statement in another server and will return the results to the client. And same things if you have other DML, so like if you have an insert that fails, it will just be executed on a new writer once a writer is promoted. This in case of MySQL standard asynchronous replication, but of course in case of TiDB, what we can do is just we retry the DML in another TiDB server. And all the features that we have this in case of host group, of course, we also have all the features that are relevant if you have just one backend server, like the caching, query write, throttling, and firewalling. We're going to discuss them in a couple of minutes, actually, right now. So the way you actually program ProxySQL and what to do is through query rules. So basically, what you do is we have a table called MySQL query rules in which you define for each type of query what action need to be performed. So like you can have caching, routing, firewall, multiplexing, and so on. In this table, we have different, So basically, you send the query to ProxySQL, the rules are being processed, and based on the contents of the rules, some action are being performed for the query that are matching those specific rules. So we have matching criteria. So basically, in this table, we have a list of columns that define how to match a query. The query can be matched based on username, the schema, and which port it connects to the client, or the address of the client, and so on. But also based on the digest. So every time we execute a query, we also generate the digest of the query itself. And we can also match the query based on the digest or on the query itself. Like we can apply regular expression on both match digest and match query. And then we take some action. And action can be, for example, rewriting the query or defining which host group the query needs to be sent. So here there are some examples in case of routing and in case of query rewrites. Or we can do other things, like for example, we can specify for how long a query can be cached, and this means that the subsequent query, if they are identical, they won't be executed on the backend server, but the query will be served from the query cache. Timeout, every time you're executing a query, you can specify that the query can time out after a certain number of milliseconds if the query needs to be retried. But also, we can have a system in which we define that a query needs to be delayed, so it should not be executed immediately. And in this way, we have a very basic form of throttling. We have different type of throttling, but this is one of the many available. Then we have mirroring. This is an interesting feature in which we are able to mirror some of the traffic into different type of host group. And sometimes we do this for testing purpose. Like we want to rewrite the query and see how it performs, so we can use this technology. Or else we want to generate an error message. So for example, if we want to block a query, we just define error message and the query won't be executed on the server, but the client will get an error saying, for example, that the specific query cannot be executed. Or else, if you want just to filter the query, like you can reply to the client with an OK message while the query in reality was not executed anywhere. And also you can have the log. So if you want, you can enable logging for some specific query pattern only. Oh, sorry, I went backward. Okay, now caching, firewalling, query rules. Here I'm going to show some example about this. Like before I was saying that ProxySQL analyze all the traffic and it also collect statistic. So for example, you can identify which are the top 5 query by total execution time, or the top 5 query based on occurrence. So like which are the most frequent query. And the statistics are in this table, in fact, MySQL Query Digest. And it is a table, so you can run any sort of query. In this case, we search for all the queries that are select statement, and we order them by count star. So we get the top 5. Once we identify which are the most common queries, and we can identify, for example, that they can be cached, we can just create a query route that says, okay, from now on, those queries are going to be cached. That's simple. Once the query is cached, in the Start MySQL Query Digest table, there was the table that I was showing before, this one, the host group for the specific query will show as -1. That means it didn't really been executed on any backend, but it was returned from internal cache. Here's an example. So like if you want to create a rule, says that all the queries that has this digest, 38B, etc., it has to be cached for first to second, and then you can also tweak it, and we can run update statement on these tables. Okay, now how do we do query firewalling? Again, quite relevant no matter what is the backend. Like you can create query rules based on username schema. Like if you want to block a specific user for running some specific query, you can use something like this. So like you specify the criteria and then you specify an error message. And here is an example. Like in this case, we create a rules in which it says like whatever query is being executed by user root, just return an error that the user cannot run this sort of query. And this is extremely useful, for example, if you are in an emergency situation and you just want to block, you identify that there is a query that is creating some problem, so you want to block only that query instead of blocking all the traffic, or you want to block just the users and so on. Of course, this doesn't scale very well if you have very complex query pattern. So we have also an more advanced features that we actually call firewall. It's very similar to the MySQL firewall itself. So basically what we can do is that we let ProxySQL run for as long as you want. During this period of time, it basically will collect all the query pattern that is executing, and then you can create firewall rules based on the query pattern that's being created. Like for example, you can say that all the query that has been executed in the last 2 hours are legit query. So you create a whitelist with those, and anything else that will be executed that is a query that was never been seen, it will just be blocked. So this is very useful if you are making code change and preventing unexpected query to hit the database. Okay, query rewrite. Query rewrite is also a feature that sometimes is so very relevant with TiDB. So like we normally use with MySQL if you have a query that has very poor performance, and sometimes improving the performance is a query just a matter of rewriting it, and sometimes just a matter of adding a force index, but sometimes the sort of rewrite can be good complex. With TiDB, it might be useful if, for example, some syntax is not available. So you can just rewrite the query using the MySQL, the ProxySQL query rewrite feature. Okay, now how are we with time? Good. Okay. We also, when it comes to statistics, we also have invisibility. We also have a Prometheus exporter. So, and this as easy as enable the exporter in ProxySQL itself. This configuration can be done at runtime, and then basically at this point, ProxySQL will have its own exporter that is built in and will export all of these internal metrics. And of course, we also provide some Grafana dashboard since version 2.1, and here is some screenshot that shows all the information that you can get. Like the information you get, there are actually a lot more, but we are just trying to put some of those metrics here. So like we have some very cool dashboard if you are interested in. Okay, a few more like statistic about query pattern, number of connection, both front end, back end, bytes sent, received, and so on. Now deployment, where to deploy ProxySQL? This is a quite complex question. Like sometimes you want to deploy the ProxySQL on the application side, like as a sidecar. And of course, depending from the type of deployment you have benefit and drawback. So if you deploy it on the application side, you have absolutely no network overhead because all the communication happens through localhost. There is no single point of failure. If ProxySQL or the application dies, they die as a single entity. So all the other application server will continue to work. They are not affected. You can have isolated configuration. So you can have one proxy with one configuration and another with a different one. Like if you want to try some different configuration, you can do this. And this allows also have a rolling upgrade. This sort of deployment has also some drawback because, for example, in this case, each one of those proxy will be monitoring the backend. So like in this case, each backend server is monitoring 3 times because we have 3 proxy. And each ProxySQL will have its own connection pool, so you will have more connection to the database server. And you need a way to also make sure that the configuration between all the proxy are identical. So you have some effort there. And also the query cache, they are not shared. So each proxy has his own query cache. So query has been cached by one proxy cannot be used by the second one. And then we have another type of deployment in which we have a middle layer proxy. In this example, there is just one. You can have way more complex situation in which you have more than one proxy, of course. The drawback here is that we have an additional network latency, of course, but also there is some benefit, like there is only one proxy monitoring the backend. Then, of course, this means less backend connection, less configuration because you only have to configure one, and there is a shared query cache. Another very common solution that we see in our customers is actually a multi-layer ProxySQL deployment, in which you have one proxy on the application server that is then connecting to a middle layer of proxy. And this sort of setup, it basically combined the best of the 2 previous listed configuration. Of course, those are the 3 most common, but of course there are way more configuration and deployment that you can have. The good important things here is that for the proxy in the application server, this proxy in the middle layer, they are MySQL backend, so you will get all the benefit of failure detection. So if any of the proxy in the middle layer fail, the proxy in the application layer will detect this and is able to handle this automatically without the client even knowing that a failure happened. So the query will just be routed through a different proxy, and this is absolutely automatic. Now, I speak about TiDB specifically. One of the features of TiDB is that basically data is being split into regions, and then you have replication within in TiKV. So each region is being replicated into multiple TiKV, and so this is basically a diagram that TiDB website. So basically, it basically shows how a single TiDB works. And like multiple TiKV here, there are 3. So that is being just into one leader, and then it's being replicated to different follower. And this is another representation of how the data is being split into regions, and regions are basically replicated through multiple KV instance. Okay, now one of the things that we have been seeing with users that they want to use TiDB is the ability of having certain type of query being sent only to followers and not to leaders, because by default all the traffic, both write and reads, is being sent to the leader. But there is the option of using these variables called TiDB replica read, in which you can specify if you want the reads to be sent to the leader or to the follower. So basically now in ProxySQL 2.05, we added the features of also tracking these variables. So if the client is specifying like set session TiDB read replica, we are able to track this. So we are able to send, to push these variables to the right TiDB server. But we also, we enable this also as a user attribute. So let me explain something about user attribute in ProxySQL. So in ProxySQL, we have these features that for each users, we can also specify some specific attribute. So this means that in this case, if we set that a specific users, like in this case, SBTest RO, we can set that the default TiDB replica reads is the follower. So this means that every time the application is using this specific user to connect to ProxySQL, ProxySQL will automatically set the variables TiDB read reads followers. So basically all the queries executed by these users will be using the follower instead of using the leader. Now we have another features that we are developing right now, that is the ability of having attributes also not only for the users but also for host group. And we are planning to have this TiDB replica attribute also for host group. So what we are going to be able to do is to have 2 different host group. One host group where we send traffic that is going to use the leader, and another host group that is where we're going to send all the queries to the follower. So in a way, we are simulating sort of read-write split in a MySQL environment. Also, we have another feature that's interesting is, like, let's speak about how TiKV and TiFlash operate. Like, this is very interesting. So, like, in TiDB, we have this concept of the TiFlash that is a column storage that is an extension of TiKV. So you have replication from TiKV to TiFlash that is asynchronous. And yeah, basically, this is how it works. So within a cluster, you have different TiKV nodes, and also you have the TiFlash nodes that are replicating from TiKV. So currently, if you are connecting using a client, you can use a single TCP load balancer, and this will distribute traffic to any of the TiDB nodes. And the TiDB nodes will then be responsible for figuring out how to execute the query. So they can send the query either to they can get the data from TiKV nodes, or they can get data from the TiFlash nodes. And but you cannot, in this way, you cannot split the traffic. So like you cannot have some TiDB nodes that are specialized for TiFlash workload, to use data only for TiFlash. Of course, if you want to do this, you can also basically configure the TiDB node and have the engine isolation. So you have this variable called engine, which you define the list of engines that you want to use and which order. What you could do directly is that you have some TiDB nodes that only use the TiKV and other TiDB nodes that only use the TiFlash. And if you do this, you can basically reconfigure everything like this. So we will have those 3 TiDB nodes that only use TiKV, and those 2 TiDB nodes that only use TiFlash. And in this case, you will basically need to split the traffic into 2. So you will have, for example, load balancer communicate with a set of TiDB and another load balancer communicating with a different set of TiDB. But in this case, you still have the client that need to be aware of where to send the traffic, because it won't be automatic. So the client need to be aware what sort of queries, and like they can use different port or so on. But the client need to be aware of this distinction. But in reality, what you can do is you can also use ProxySQL to do this works behind the scene, because you can basically create in ProxySQL 2 host group. One host group for the TiKV engine and another host group for TiFlash engine. And then you can use either different users, or you can create query rules that identify the query, and based on the query, it will send the query to either a set of TiDB nodes or a different set of TiDB nodes. So basically it will look like this. So like the client will send traffic to ProxySQL, and the client doesn't really need to know where the query is going to be sent, but ProxySQL is able to analyze the queries and will either send the query to host group 0, where it's connecting to TiKV, or to host group 1, where as storage we are going to use the TiFlash. Also, another interesting thing is that with TiDB, you can also specify, you can also send hints. Like you have this hints that's called read from storage. It's very interesting. So like technically, the client can also tell ProxySQL what to do with the query. So if the client, through a comment, specify read from storage and use TiFlash, basically the client can tell ProxySQL to send the traffic to host group 1. And we are done. Thanks. Question?
So my question is around how does the ProxySQL be able to handle the maybe slight different behavior on different database engine? Because recently we run into an issue that we upgrade MySQL to an upper version, and the connection error code changes, so that broke our client-side code of how to handle like when the connection is close by a server when there's a long time of inactivity.
Okay.
So since ProxySQL handles so many different
ProxySQL doesn't change the error code in the message. So like if MySQL is returning a different error code, the error code ProxySQL will send it to the client, unless it is one of those errors that ProxySQL is aware of, and like the server died. Like in this case, ProxySQL is able to identify that this is a specific error code, and we will just re-execute the query. But for the majority of the errors, the error message is sent to the client. But again, it really depends from the error code. So like if you can give me some example, I can get a more specific answer.
Yeah, in this particular case, it's kind of like connection-related error. So it's basically when we have 8 hours of inactivity,
okay,
the server will close that connection.
Yes.
So the connection is basically dead.
Yes.
So I wonder if ProxySQL will detect, oh, I have a connection pool, but one of the connections is already dead.
Yes. Yes. It is able to detect this automatically. So ProxySQL is able to ping its own connection on a periodically. That is configurable by default is every 2 minutes. So every 2 minutes is sending a ping to every connection to keep it alive. But this is not a requirement. So it is able to detect that a connection died even right before executing the query. So if a client sends a query to ProxySQL, ProxySQL will identify a connection or where to send the query, and it sends the query. If the connection is closed, it says, okay, this connection was not good. Let me take another connection from its own connection pool. It will send the same query. So if the connection from ProxySQL to the backend is closed, it's not a problem, and the client won't get any error. And because it's actually is able to handle scenarios in which the whole backend dies. So like one connection disappearing is a sub-case of this.
So I have a question about, is there anyone using ProxySQL to building a multi-tenancy application, allocating the quota for different tenants or?
Yes, and we have way different ways of doing it.
Wow.
Yes, yes. Like we have one of the. Oops. Let me see if I can go back to the slide about the host group. Like we have many, but I'm telling you one of the most interesting one we had recently. So here, when I was showing this graph, I said that one single server can actually be in multiple host group. And we have a situation recently of a user that he had, was a multi-tenant environment in which they put basically the same server in 1,200 host group. The same server. And they had the limitation of 10 connection per host group, per server per host group.
But
so in reality,
the connection level, for example, if one customer sending a select star from table,
yes,
that is very busy, very huge,
yes,
a lot of resource consumption.
yes. It's actually solved this problem because we are limiting the number of connection. So even if it is one single server, we create, this client was creating 1,200 host group with only one server, the same server in every of those host group, and basically was limiting the number of connection, 10 connection. So every user had maximum 10 connection for the backend.
So I think this idea of a multi-tenancy situation, having different TiDB SQL-speaking servers is a really good idea. That's something that's that I think would be more valuable than the scenario of trying to send things to either TiDB or TiFlash. Part of the magic of the way the HTAP stuff works in TiDB is that the optimizer in TiDB actually decides whether it's more efficient to use the row store or the column store. And in fact, as we saw in one of the presentations earlier, in many cases it can use both in the same query.
Yes.
So that type of scenario you explained would make it impossible to use both of them in the same query. But I think much more valuable, and what Ed is suggesting, I think, is some customers, maybe someone we know is paying more, or we know that they have queries that require more memory. They would have access to a host group of TiDB instances that were maybe on bigger VMs, just had more memory on the VM. So when they execute a huge join, there's more memory available on the TiDB server, and they get isolated access to that memory. Whereas other users that have lower needs can go to a different pool of TiDB server instances that are less expensive and where a failure might not impact a critical application. I think also something where you're doing a large reporting application, something where you're performing huge queries, you know that it's going to be something that uses tons of memory. You either have those be executed by a separate user, or you have a heuristic or some other mechanism to identify those, and then those can be sent to one of the other backing TiDB.
But using this sort of technology, we're also able to do some sort of quality of service. Like, for example, we can identify some query pattern and decide, okay, for those query pattern, this query can be executed as fast as possible, like absolutely no throttling. But then any queries that we do not know, that we are not aware of them, we only dedicated 5 connection. So we create a contention there. So like any expensive query that is not the production query, they're just being funneled in those 5 connection.
So here's a really cool idea for a ProxySQL feature, or maybe you can already do this. So TiDB servers are completely stateless.
Yes.
And they take very, very little time to start up. If you're using Kubernetes, adding a new one can take just a couple seconds. So if you have a query that you know is executed periodically, and you know it uses a huge amount of resources, maybe ProxySQL, when it actually sees that query come in, could start a VM, especially for that query, give it like 256 gigs of memory, and then once the VM starts, send the query to the VM. And then when it's done, you kill the VM. So you pay for it to run for 30 minutes or 5 minutes
Yeah,
instead of
that's actually a very good idea. Yes.
Well,
Yeah, it's cool.
This means that we need to create a hook before the query is being routed.
yeah.
Yeah, it's basically a serverless proxy. Yeah.
Yes, basically we are seeing the query coming.
Yeah. Or
It
even
can
it
be
could
implemented.
happen when the user authenticates, because you know that this user is dedicated to that query. So you're not having to like block the query, but like the user, when it authenticates, you start to. That'd be cool. You
Before
should
I
write
was
that down.
mentioning
That
that
would be amazing.
we have the scheduler. But it doesn't matter. We have the
But
scheduler.
don't
It's
you
basically a
need to
features
track
that.
the latency, because if it figures out while the query is
Of course, but this is a query that's going to take 30 minutes to run anyway.
like more of batch.
So yeah, this is something where you know he has a huge demand for resources, and it might not even be possible to execute this query on a standard size TiDB server instance, just because it requires a huge amount of memory or something.
Yeah.
So instead of having the operating system OOM kill your other TiDB
Yes.
server instance,
Mm-hmm.
or
And-
spill a bunch of stuff to disk and have that be slow, you just say, oh wow, it's going to be way better for everyone if we wait 45 seconds to start executing this query while we start the VM.
No, that's good.
Yes,
Basically,
it
it's
can be
like
done.
a
We need to create a hook
firewall
for it, but
mechanism.
yes, can be done.
We see there's an ORM for the large query, and the proxy layer can
You basically.
Like once we get the query,
provision
we analyze the query and we can create some rules. It says, okay, when we see this query, we should take some action. And part of the action is creating a new cluster.
Would there be any way to do it programmatically from a slow query log?
Yes, we can use the scheduler. Like the scheduler regular interval can figure out, okay, probably at around this time is going to execute a query. Let me pre-allocate a cluster.
Or the request can come from your REST API.
Yes, we also have a REST API that
the request
can be used
come
for
from
this.
there, and the query then will be processed inside internally with all the spinning up of the new TiDB and
Yes,
whatever
that's
else.
correct. We can also do this. There are multiple ways of doing it. Yes.
I also sort of question whether we might want provisions of a really big instance for the entire execution of this query, because over the course of a query's execution, resource consumption can go up and down over time. So for optimal efficiency, I want dynamic scale up and scale down over that 30-minute period.
Well, maybe for a single, changing the resources for a TiDB server instance while it's running, I don't think is very practical. Also, there's typically the amount of memory that's required to execute a query in TiDB is just going to kind of keep going up, and then you have to drain that to send results to the client, and then by the time you've sent the results out to the client, it's time to kill the
Maybe this
instance.
feature added though for things like Spark or Hive, where they actually do support dynamically allocating more or less resources during query execution. It's a common thing for
Yeah.
OLAP frameworks.
Yeah, there might be ways to do that. We're talking here about just starting extra VMs that have dedicated hardware, but yeah, I don't know. Anything's possible.
Could the application actually send a query that is not a real query, but as an instruction? Like tells ProxySQL start a cluster.
Well, the application can, right, anything, we can have it do anything we want, but I think typically you would want to isolate the application from the deployment infrastructure, so the application probably shouldn't know what's happening with
The,
resources and stuff.
the command could actually be some sort of,
Like a hint for the amount of resources that are
yeah,
expected to be used or
yes,
something.
exactly.
Yeah, sure.
I have a different question actually. You mentioned that ProxySQL supports automatic detection of failures in the past.
Yes.
Is that different when you're interfacing with TiDB system?
No, it's the same. Like what is able to detect, for example, is that the backend, the query failed while executing.
Okay, so basically a query failure will trigger
A retry mechanism.
sorry,
A retry mechanism.
retry mechanism.
Yes.
Will that involve moving that host or something like that?
No, not necessarily. Like it could be a transient error because, for example, somebody killed the query, or and no, the backend was restarted, because we're assuming that the backend is a MySQL, but could be a load balancer. So you might have lost connectivity for just a short period of time. So we have a mechanism that if we get too many errors in a short period of time, then we temporarily disable the host for a configurable amount of time, normally it's 10 seconds, and then ProxySQL will try again to use that server. So there is always some retry mechanism. Now, if the server actually is dead, this is being detected by the monitoring module. So the monitoring module is also checking the health of the backend, and if it detects that the backend is not responding anymore, that is offline, or the ping take forever, at this point, yes, ProxySQL will disable the server completely until monitoring detects that the server is healthy again, and then it brings back to online.
Are those health checks configurable?
Yes, everything is configured.
Can I add my own custom options if I want to?
Yes, you have the schedule, you can also do a custom health check as well. Thanks. Thank you.